Right, hello, I'm Gina Czarnecki, I'm an artist.
I'm John Hunt, a research scientist.
And together we made a piece of work called Heirloom, which we're doing this presentation for so we can present in our absence. And we're going to give you a little bit of insight into the making as if we were there in front of an audience.
Yeah, very good. Hi.
So what Heirloom is really is the growth of skin cells from a non-invasive process of my daughters whose faces were cast when they were 11 and 13, and the inventions that we've had to make to be able to grow those cells outside of a laboratory and keep them alive and then lift them and preserve them to create a 3D structure of cells.
Yeah, so there's a significant process we went through over a number of years to work out what would be required to take what are very exciting regenerative medicine and stem cell techniques into a closed system whereby we can take it into a public space and still have those cells grow and still have those tissues develop and develop something like skin in the physical form of a face.
And I mean, my perception of the benefit for this medically is maybe if you consider children facial burns, where at the moment you can grow skin plasters, not necessarily from buccal swabs but from plugs of skin, and you can grow them flat, and then if you stretch them over the part of the damaged face, they have to stretch and distort.
That's right. So many of the bandages at the moment are just grown flat, and then you can picture any part of your body that you like and it's not flat. So if you create that sheet and then try and wrap it, you will always end up with imperfections, tears and creases, where if we take a three-dimensional scan and rebuild that as the scaffold, then we grow the cells and the skin in this case on it, then you have that three-dimensional match such that when you take the tissue off, you can then place it perfectly in 3 dimensions on the patient, on the person that you would like to treat.
And potentially that would be over a 2-week growth period from the people's own cells.
Yeah, that bit does vary, and we've had some fun with Heirloom trying to develop the timing of that. So in the first time we ran it, then of course, such as human beings, we panicked a little bit and wanted to make sure we got the results, so we had everything and it just grew too fast, but then we knew it would grow. So after that we've then finessed and developed the procedure and the environment such that we can grow it more slowly, and now we can actually time it. So we could accelerate it to be as fast as a fortnight, but we could take it out to be as long as 3 months. Which
we've done for some of the exhibitions
that
have had the live version of it. I suppose we started this like 2013, we started talking about this, didn't we? And it was really because John had worked with a number of artists previously, and I was interested in creating, I guess with teenage girls that are obsessed with their appearance all the time, and being an artist trying to survive professionally as an artist, it's about leaving something of value for your children. And that's why it's called Heirloom to some extent, but also working with medias that anybody could technically get hold of and use if they've got the funds or the resources to do it, and manipulate how then your cells in your body have become plastic in a medium like any other media. So it's a lot of interconnected things. And then Saskia and Lola came to your lab to work with him. They found out quite a lot about cell growth.
Yeah, to give their cells. I think Gina touches on a very important difference between this piece of art and the science and the tissue engineering process. If we were to grow this in the lab as a scientific experiment, we would need to reproduce it, and we would need to reproduce it at least 4 times and it be perfect so that we could analyse the cells. That's completely different from being a human being and being an individual. If we create something for one person, the person is not perfect, and does the implant for that person therefore need to be perfect. So this is an opportunity to take the experiment out of the lab and treat every single procedure as one personal experiment. And what will you end up with? What will you produce in that one procedure? Will you end up with a skin structure, or will you end up with something else? And the value of being able to take that one single experiment all the way through the process to produce tissue at the end is really valuable to me as a scientist, because I can take all of that laboratory research out, I can put it in a closed system, and it be completely hands-free. So it's completely out of contact with me manipulating it on a daily basis, manipulating the cells on a daily basis. We can control the environment on a daily basis, but we've completely taken away the experimental procedures that I might do in the lab on a daily basis. It's now completely hands-free, which is very exciting.
It's also exciting for a lot of people to develop what are bio chamber, place where you can sustain life outside of the lab with ubiquitous technology, stuff that's readily available, that anybody can get their hands on to some extent, apart from the media which John developed specifically for cell growth and cell boosting.
Yeah, that's right. It does touch on the other aspect of this. If it was an experiment and it becomes infected, then we would throw that experiment away, because the infection is an unknown variable of an unknown amount, and I would never be able to reproduce it because I couldn't precisely reproduce that infection. In this case, where it's a closed system and it's one experiment, we could treat, and we have treated, heirloom with antibiotics and with antimicrobials to treat the living tissue to recover from infection and overcome the infection. And again, that's a very interesting approach, because really, as a personal treatment, there is no reason why we wouldn't be able to treat the tissue as it's growing. As an experiment and providing the quantitative data, we certainly couldn't do that. So it does give us another very interesting aspect to developing life outside of the body and then treating that life such that it can go forward.
I was also, well, I am increasingly also interested in about working on artworks that have got potential use for a massive public, that they could actually really help and not only exist within a gallery system, but have functional lives that benefit people's lives outside of that system as well. And that's, I guess, through the last 30 years of being an art practitioner and wanting to remain an art practitioner without having to get a separate profession. So I kind of, we've had the questions: is it art? Is it abusive to the kids? Is it, it's really one of those bits of work which is directly in the middle of all these different things. It's indefinable. But I know both of us have got an ambition that we then lift the portraits that have been preserved and to retain their 3D structure. That's quite a difficult task using glass, which we're currently using. Of course, we can 3D print the faces, we can buy polymers that are degradable, and leave the skin intact to create a really contemporary portrait in new media.
Yeah, so there are lots of technologies and tools that we could now apply to this to create that three-dimensional space such that the lift-off would be very practical. What we would like to do, and why we've presented heirloom on glass, is to get this kind of approach out in the public eye, and to raise those questions about what are the issues. Are there issues with this kind of approach? Can you see in your own personal lives or in your family lives that you would have a use for this? If this was available, would you like to make use of it? What would you like to grow? What would you do with this kind of technology and this kind of approach? It's really to put it out into the public space and ask those questions of the public. This is what science and art are able to present to you today. What would you like to do with it? Where would you like to go with it? Is it an issue? Are there any issues for you with this?
Of course, we're already able to 3D print organs, and the skin as another organ is perceived in such a different way because it's the surface of our bodies, and what most teenage girls are totally obsessed with as well. So I hear conversations quite a lot about the plasticity of appearance, like Botoxing faces or plumping up lips, and the kind of cosmetics industry, and the potential of the byproduct of research like this being used in the cosmetics industry, which it wasn't against, but it certainly wasn't for. And there's, if you can regrow your skin from a 3D print, like the scanning software will be in your smartphones very soon, you can keep 3D portraits of yourself through the years, and potentially then regrow your own skin for implants in the future as well.
Yeah, or you could grow some of your own skin and test your own cosmetics and your reaction to those cosmetics yourself. There are many different places you could go with this. You don't have to grow a whole face. You could grow a small area and do your own matching and balancing for what you would like to do with your skin and how you would like to treat and use your skin. You could find out what you could do with the skin you're in, really. That would be very interesting.
Yeah.
That'd be quite a fun thing to do.
We're also in conversation with genetics about it, because obviously if you've got a sample of stem cells and you've got a physical appearance captured with scientific accuracy with the big scanners from FaceLab, there's a potential of also creating clones. That sounds like science fiction coming from me, but if you talk about that, it'll appeal less like fantasy.
Well, genetically you could create a clone, and here with the sort of 3D imaging that we've got now, you can create a clone that physically matches you. So of course, in creating a clone and growing them from an embryo, the genetic match might not look exactly like you, but here there is the possibility that yes, you can match that genetic information to your three-dimensional form, and then your clone really truly might look exactly like you. That is well, it's scientifically feasible, but exactly what that would look like, who knows? And that is actually still currently illegal. It's very important to say that. So
yeah, it's also the ethics you have to go through to actually collect spit from someone as well. But the amount of people that have had their faces scanned, so their information of their physical type is in a data bank of images. And you don't have to give you permission for images. You can take someone's image and reconstruct a three-dimensional form from 2 seconds of video. People don't have to give their permission. And that raises a whole load of other interesting questions as well.
Well, today, in the world today, your image must be taken at least 20 times a day from various cameras, monitoring movements, and that's very simple information to rebuild back into a three-dimensional structure, if you were going to collect all of that data.
Yeah, so these people, we've got about 150 now, I think, all being scanned, have all willingly contributed without clearance forms, but they give their information willingly. And they're beautiful little three-dimensional heads that we're printing off of everybody. That's a growing collection of participation in the artwork, and that's become increasingly important for me over the last 10 years, is actually what people will give in terms of themselves to participate, and why people do that. It's really interesting and very deeply personal a lot of the time. So where are we going with this now?
There are multiple places we can go. Artistically, there are many avenues to explore, and scientifically there are many avenues to explore, as well as having the public debates about what does this mean, are there issues arising with this. So scientifically, we would like to develop this possibility to create tissues in three-dimensional form and really scale those up such that we can decide how much tissue we have and how long we can keep it alive in the lab or in the closed system, and then lift it off and provide it as a patient treatment. So at what point does it reach maturity such that it's ready then for clinical use?
And I think the exhibition's been, I suppose, on tour since it was made, and will be on till the end of this year pretty much. So that's done really well, and every time it's shown in the live, the mock-up or the documentary version of it, obviously it's expensive to pack up and travel with all the cells and the media. So we have 3 different versions of it, and every time it presents new challenges and new questions, and it grows and adapts to different spaces within different contexts as well. And ideally we'd like to see the resulting portraits, the artefacts of the first lift that are still on the first glass cast, be part of the portrait gallery exhibition.
That would be lovely, yeah.
So I hope that's answered some of your questions that you might have had. Clearly you can always contact me by email.
And you can debate it while you're there.
Thank you.
Thank you.